6.1 talks about areas between two curves. Suppose we have the following two curves. Let's say we have some, to match the definition, let's say you have some function y equal f of x. Now, if I want to find the area between a and b of f of x, well, we know how that works. If I decided to run vertically, then the integral from a to b of f of x dx would simply run from the x-axis all the way up to the function. That's how an integral works. Now, if I had another function, g of x, but g of x is always less than f of x, so it's beneath it. If I integrate from a to b of g of x dx, then that would find that area. So again, it will run from the x-axis to the function. But what if the area in question that I was looking for was really this area only? What if I didn't want this area? So what if the only area I wanted would be this? Then the way to do that, you would say, well, look, if I integrate the green, that gives me the whole thing. If I integrate the purple, that gives me that part. If I subtract the two, I'll get the area that I want, which is this shaded region. But you also notice that, wait a minute, those two integrals have the same limits. They're in terms of the same unknown, so I could simply say f of x minus g of x dx. And the way we're going to make use of this and make it simpler, if I run my vertical rectangles, I take the top minus the bottom. So every time you look at vertical rectangles, think of it as an arrow, the top minus the bottom, and that always works. And that's what this definition is saying. So let's practice that really quick. Again, I'll show that only in the first problem. Suppose I'm interested in finding the area between those two curves. So for the following exercise, determine the area of the region between the two curves in the given figure by integrating over the x. Okay, over the x means they want us to run vertically. So the rectangles are vertically. So this is what you have to do. You're going to say area equal the integral. Now, if I run the integral from, I need to know where this point is and where this point is. Well, how do you figure that out? You have two equations. You set them equal to each other. So that's where you start. You start with, where does x squared equal 3x plus 4? You know what? Let me do this in the right order. So that's where we begin. And that means, where does x squared minus 3x minus 4 equal 0? That's when x minus 4 into x plus 1 equals 0. X equal a negative 1 or a 4. Okay, so this is really at 4. And this is really at negative 1. So if I run the integral from negative 1 to 4, and if we're running with respect to x vertically, that's dx. That's why it's x equal negative 1 to x equal 4. The one thing you have to ensure when you do this, you have to ensure that the top is always the same, and in this case it is. So the top minus the base, and the base happened to be the parabola. Of course, this problem, you don't need parentheses around this part, but I suggest you put parentheses in case you need it. Now, setup do not solve, that would be how the integral looks. This is nothing more than the integral from -1 to 4 of -x squared plus 3x plus 4 dx. You know how to do that. That's f of 4 minus f of -1, and you get a numerical answer. I'm going to set up all of these problems, and I'm assuming you could work them out. How about this problem? I'll work out a couple of them, but that's nothing more than simple integration. Most likely on your test, I'm going to ask for the setup, so make sure you know how to set that up. I'll tell you what, I feel guilty now. I could work out this problem really quick. I don't even need that part. I could have said, wait, I know what that is. That is 3x squared divided by 2 plus 4x minus x cubed divided by 3 evaluated from -1 to 4. That is 3/2 16 plus 16 minus 64 divided by 3 minus 3/2 minus 4 plus 1/3. So there it is. That is 24 plus 16 minus 64 over 3 minus 3/2 plus 4 minus 1/3. So that is 24 plus 16 minus 64 divided by 3 minus 3/2 plus 4 minus 1/3. 125 divided by 6. You want to leave it in decimal, you can. Now on a test, if I ever ask you to work it out, you could just leave it like that. You don't have to add fractions on an exam. Normally I'm going to ask for a setup more than anything. So setup, do not solve. Tell me how this area works. Well, again, we're running with respect to x. Here I notice that this is a bit trickier, and the reason for that, I notice here they're running between 0 and pi, but if I run my vertical rectangles, I notice in the beginning the top is the cosine of theta, and the bottom is the line, and the line is y equal 1/2. This is with respect to x. That runs from x equals 0 to x equal 1. Now I notice from 1 all the way to pi, if I run my, and this compensates for negative as well. Remember, if it runs below the x-axis, we have to take the minus. If you take top minus bottom, that compensates for all of that for you. You just have to worry about vertical top minus bottom and horizontal right minus left, and that will always get you the area. And area is always positive. If you ever get area to be negative, that means you made a mistake. If I run from 1 to pi, I notice in this case that the top is the blue, and the blue is the line, 0.5, minus the bottom happened to be the actual cosine. Okay, then it's in terms of theta, not x. Okay, I'm so stuck on x, forgive me. They made the x-axis theta. Okay, there it is. Actually, okay, they messed up. This is theta. All right, and again, this is what the sine of theta minus 1/2 x evaluated from 0 to 1. This is 1/2 x minus the sine of theta evaluated from 1 to pi. So here you get sine of 1 minus 1/2 minus, if you put 0, that's a 0. And here you get half of pi. Sine of pi is 0 minus 1/2 minus sine of 1. There it is. Sine of 1 minus 1/2 plus pi over 2 minus 1/2 plus sine of 1. And the whole answer turns out to be pi over 2 plus twice the sine of 1 minus 1. Again, set up, do not solve. That's all I want. That's what I'm going to do for the rest of these problems. I'm going to set them up assuming you can integrate. The worst case here requires a U-sub, but that doesn't even come up. Okay, now instead of doing x, we could do y. In this case, they want us to run with respect to the y. So when you set up the integral, you're looking at y equal to y equal 0 to 1. And you're going to run your rectangles horizontally. And do you see horizontally, the right side is the line. So since this is a dy, you can put an x in there. Well, what is that? Y equal x or x equal y. And the left is the blue. So right minus left. The left is the blue. The blue is x equal y squared. That would be the setup. And that's my answer. Okay, now I know you're not responsible to integrate exponentials if you are at Pasadena City College. If you're component, you do that. But just for practice, just the setup, you're going to do this in your second semester calculus for Pasadena students, but let's practice anyways. Y equal e to the x. So now we're running this with respect to x. They want it vertical. Y equal e to the x. Let's say that's 1. The graph of e to the x looks like that. The graph of y equal e to the 2x minus 1 grows square as fast as that. But if I put 0 in, I notice that's 1 over e. So it's 1 divided by 2.71. It's about a half. So this graph looks like this, and it grows very fast and overlap that one. Okay, let me get that work here. Now, the deal is I need to know where they meet. It says the following graph the equations, shade the area of the region between the curves. Determine if you're gonna determine its area. They want us to run x equals 0, x equals 0 is a vertical line. So we know the area is right there. That's the area they're talking about. What I need to know is, where does this point happen? That's when you take, and again, algebraically, everybody should be able to solve this. But calculus of exponentials and logs appears in second semester for Pasadena students or junior college students, and for university, that's the first semester. So this means that x equal to x minus 1. That means negative x equal negative 1 or x equal 1. Those cross at 1. And you can check. Put 1 in there, you get an e. And put 1 in there, you get an e. There you go. So area is going to equal, if I'm running this with respect to x, I'm running vertically. Vertically, I look at my arrows. The top is always the purple. The bottom is always the green. And that's going to run from x equals 0 to x equals 1. And that's how we're going to do all of these problems. Now, again, just the setup. Don't worry about how do you take a derivative or antiderivative of exponentials, because in Pasadena we do not learn that until the second semester calculus. Okay, how about this problem? I have y equal e. That's a horizontal line. That's at 2.71. 2.71. So it's a line that looks like this. E to the 1. Exponential growth. Exponential decay. The region they're talking about is this region. Now, in this problem, I'm going to show, even though they say go with respect to x, I'm going to set it up that way. We're going to say area equal the way they want, the integral with respect to x. Now we're going to notice that, wait a minute, and I'm going to copy that and use it again. So I'll show you what the price is, and that's something you have to make a call for later on. For now, Let's just follow what they want. If I run this vertically, I'll notice that, wait a minute, top is the orange and bottom is the purple. The purple was e to the negative x, yeah? But, and that runs from, I need to know what this point is. Take the orange and set it equal to the purple. So if the bases are equal, the powers are equal, x equal -1. So that's from -1. Why am I stopping at 0? Because I noticed from 0 and on, the bottom is no longer the purple. The bottom now is the green, which indicates I need two separate integrals. This problem cannot be done in one integral. I'm going to run from 0, and I need to know where that point is. Well, that's simple. Where does e to the x equal e to the 1? That's when x equal 1. So we know this is 1. And here, the top is also the orange, but the base is the green. And that's how the problem's done. Now again, just a setup, that's a setup. If I had a choice, and I don't in this case, but if I had a choice, I would say the area is the integral, and I would run this in terms of y. What's the benefit of running this in terms of y? Well, if you notice, if I run my arrows horizontally, it seems the green is always on the right and the purple is always on the left. So the green is always on the right and the purple is always on the left. But we have a problem. Can you see what's wrong with what I just did? There's a price for that. This can be a dy and this would be a x. Oh, and it's going to run from y equal 1 to y equal e, because now I'm looking at it horizontally. If this is a dy, this should be x equal and x equal. Let's go to the green. The green equation says y equal e to the x. Doesn't that mean x equal natural log of y? So instead of writing this, you really want to write natural log of y, which is y equal e to the x. And instead of writing this purple, you want to say, well, natural log of y equal -x. So x equal negative natural log of y. And my answer will be again, I know that Pasadena City College students do not know how to integrate natural log yet, just the setup. But you should follow directions, whatever the problem says. How about this problem? If I'm going to run this problem from sine of pi x, the period is 2 pi divided by pi, which is 2. Oh, 2 we said, right? So I'm enlarging that to see it. That's how a sine wave looks like. Okay, this is y equal to sine. The period is 2. This is half of it. This is 1 half, 2 halves, 3 halves, -1 half, -2 halves, right? -3 halves, and -4 halves. Now, y equal 2x, 0, 0, 1, 1, 2. Okay, not the best. Oh, come on. Let me get, oops. Let me get that part. No. Oh, come on. What did I just do? There we go. Let's say it's like this. There we go. Better. So we're talking about this region. And we're talking about this region. And again, they want us to run. Oh, they say x is bigger than 0. So only that region. So in that case, area equal the integral. They want us to run vertically. That means x equals 0. Now, to x equal 1/2, we could test 1/2. Put 1/2 in there, that's a 1. Put 1/2 in there, sine of pi over 2 is 1. They do cross at that point, that's correct. So that's from 0 to 1/2. And then what? If you run vertical, isn't the top the black? And isn't the bottom the purple? And there it is. That's the setup for that. Area. How about this graph? A bit tricky. I'm going to enlarge that as well so we can see it. So let's say a cosine wave. Cosine, let's do in green. Let's do a sine. Okay, that's y equals sine of x. 2 pi, negative pi, negative. So I don't have to go that far. It's between negative pi and pi. And let's do a cosine, assuming that's a 1, of course. The graph looks something like this. And when they say the area between, they're talking about not only those. They're talking about this region. But they're also talking about this region. Well, what do we have to do? We have to figure out where they meet. Where does sine of x equal cosine of x? Well, think about it. The reference angle is pi over 4. Well, this is pi over 4. I figured that out. That's very good. But also, in this quadrant, they're both equal, right? So here, sine is positive, cosine is negative, they can be equal. And here, cosine is positive, sine is negative, they can be equal. In quadrant 1, they're both positive, and in quadrant 3, they're both negative, so they're equal. What is that angle? Well, if you run in negative rotation, what's pi over 4 in the third quadrant? Isn't that at negative 3 pi over 4? Because if you run in positive, you exceed pi. That's this one, but we're just going to stop at pi. So this is the region we have. We're going to run area to be the integral. Let's see how this works. We're going to start from negative pi to negative 3 pi over 4. The arrows run. The green's at the top. And the purple's on the bottom. The purple is the cosine. Okay, well, that's that region. Plus the integral. I'm going to run from negative 3 pi over 4 all the way to pi over 4. Do you notice here that they switch? The top is the purple and the base is the green. And I need one more integral. Do you notice here they switch from pi over 4 all the way to pi. The top happened to be the green, and the base happened to be the purple. There is no other way of doing this problem. It can only be done in terms of x, and it requires 3 integrals to set up. Now, if we're going to go sideways, x equal y cubed. X equal y cubed is kind of like you're saying y equal cube root of x. One of those. And x equal 3y minus 2. That's a line. You could say that x plus 2 equal 3y, or y equal x over 3 plus 2 over 3. So go 2/3 up, rise 1, and run 3. Draw a line. Now, okay, well, we gotta see, are they talking about this? Now, how many times these intersect? Well, that's simple. You set those equal to each other. You set y cubed equals 3y minus 2, y cubed minus 3y plus 2 equals 0. That doesn't factor with the traditional method. That's okay. Possible factors are plus or minus 1 and 2 divided by plus or minus 1, which is plus or minus 1 and 2. 1 works. If I throw a 1 in there, 1, 0, negative 3, 2, 1, 1, 1, 1, negative 2, negative 2, 0. That is y squared plus y minus 2. So that's y plus 2 into y minus 1 times y minus 1. So we get y to be 1 and negative 2. So y equal 1. Let me check what that means in a minute. So that tells me that my graph is off. You gotta be really careful with these. Graphing is half of the problem. That's why you're required to do all of these graphs before. That means the graph looks like this. I only have a crossing at 1 and at y equal negative 2. I should have extended that better. There. So these cross at negative 2. That's what that tells me. Well, in this case, I am better off running with respect to the y, but they suggested that. Actually, it doesn't matter in this case. Because, yeah. And here, I noticed that if I run my horizontally, the right is always the cubic, and the left is always the line. Make sure to use parentheses. And that's going to run from y equal negative 2 to 1. And that's how you find the area. So graphing is pretty much half of the problem. A rough sketch will do most of the time, but every now and then it gets tricky like that, and you got to be careful what type of graph is it. Same here. So x equal 3 y squared. So x equal y squared is a graph that looks like this. Negative y squared minus 3. So y squared minus 3 will run to the right, something like this. This is y into 1 minus y, so it crosses at 0 and 1, and it's upside down, so it looks something like this. Okay, well, the region in question is right there. Again, in this problem, it's better to run dy. The reason for that, if I run sideways, the right is always the purple, the left is always the green. But if I run vertical, that's not the case. I'll need 3 integrals. Well, first I need to figure out where does negative 3 plus y squared equal y minus y squared. That's when 2y squared plus y plus 3 equal to 0. Let me make sure. No, I messed up. The algebra is very important. So I'm going to move that one there. So that's when 2y squared minus y minus 3 equal to 0. If that factors, that's fine. If it doesn't factor, you use quadratic formula or complete the square. A 3 and a 1, you want a negative and a positive. There we go. So y equals 3 halves or negative 1. So I know this is negative 1, and I know this is 3 halves, because my graph is not a grand scale. So I know that area equal the integral. I forgot what the y's are. That's the graph and the intersections are half of the problem. The rest is literally running left to right. Well, right is the purple. The purple is y minus y squared minus the left. The left is the green, which is negative 3 plus y squared. Make sure to use parentheses around those, right? Or simply I could say it's the integral from negative 1 to 3 halves of y minus y squared plus 3 minus y squared, negative 2y squared plus y plus 3, and we know how that goes, right? That is negative 2y cubed divided by 3 plus y squared divided by 2 plus 3y. And there it is. Setup do not solve will be simply that answer right there. Solve, then you work it out. Here's another problem. For the following exercises, graph the equations, shade the area of the region, determine if you want to integrate with respect to x or y, and go from there. Whichever is more convenient. Y equal absolute value of x is, center that properly, 0, 0, 1, 1, negative 1, 1. So it's a graph that looks like this. And I'm enlarging the scale so we can see it better. Oh, this one's not that bad. Okay. Some of those, it's hard to see where they intersect. This one is not one of them. Y equal x squared minus 1. You go up to 1, and it's an upside down parabola. So the region in question is that area. If we want to find the area, it seems it is better to run this with respect to x. Reason for that, the top is always the green and the bottom is always the purple. If I run sideways, here it's purple to purple, and then once you get to this line, now it's green to green. You don't need 2 integrals. So I'm better off running this vertical, because the top is always the green, and the green is x squared minus 1, minus the bottom is always the purple, and there, 1 integral will do. That's what we want. And I could figure out where that is. Where does absolute value of x equal x squared minus 1? That's when x equal x squared minus 1, or negative x equal x squared minus 1. Well, if you solve this, 0 equal x squared minus x minus 1, or 0 equal x squared plus x minus 1. And let's see how this works. This doesn't factor, so I would say x squared minus x. I'm going to move that one to the other side. I complete the square instead using quadratic formula. You're welcome to use whatever you want. Take half of the middle number, which is 1, and square it. Take half of the middle number, which is 1/2, and square it. So I'm getting x squared. Oops, the right side becomes x minus 1/2 squared. The right side will be 5/4. Square root both sides. Now this is going to give the same solution, redundant solution. So There it is. Now let's see. Oh, I graphed it fully wrong. Oh boy. Sorry about that. The first one is right. The green is a parabola shifted down 1 unit. You guys say something. What is wrong with you people? You should tell me when you see a mistake. We're talking about this region. Oh crap. How did that happen, people? So we know that they cross at 1 minus radical 5 divided by 2 and 1 plus radical 5 divided by 2. Now why am I not so convinced? Let me double check what these numbers are. If I take 1 minus square root of 5 divided by 2, that is negative 0.6. That doesn't give, but if I take 1 plus square root of 5 divided by 2, that is 1.6. Okay, that seems to be it. That's true, but that doesn't seem to be. That should be smaller than negative 1. Well, let's see then. It seems this second piece is going to give me the second solution. So one of those is extra. I'm looking at this part right here that says, let's see, 0 equal, this part that says x squared plus x. Take half of the middle number, which is 1/2, and square it. It seems to be the same, but this is plus 1/2. And when you square it both sides, so x equals negative 1/2 plus or minus radical 5 over 2. Well, here I'm going to get x equal negative 1 plus radical 5 divided by 2, or negative 1 minus radical 5. There you go. So that point is negative 1 minus radical 5 divided by 2. I need to be smaller than negative 1. So when I integrate, let's see how this works. Now we have a problem with this. Why? I can't run it from this to this. I'm going to say that and I'm going to switch everything now. Sorry about that. If I run my vertical lines, you notice the top is always the purple, right? I'll get to the purple in a minute. Minus, the bottom is always the green. And I'm going to copy that again. But when I look at an absolute value, for me to be able to work this out, from negative 1 minus radical 5 over 2, when x equal that, to 0, the absolute value is negative. And to drop the absolute value symbol, I need to check where is it negative or positive. Recall absolute value of x. If x is negative, you have to put a minus in front of whatever was inside the absolute value. If x is bigger than or equal to 0, you just drop it. Since for these values of x, this is negative, I have to put a minus there. And to the right, since from 0, let me just separate that a bit more so you can see it better. Here we go. To 1 plus radical 5 divided by 2, since the absolute value is always positive, I just drop the absolute value and I don't need it. And that's pretty much it for this section. I need to modify the homework slightly so Pasadena City students could see it. Cal Poly will have its own and Pasadena will have its own.